In a 17th-century observatory, Johannes Kepler is about to reveal a discovery that will forever change our understanding of the cosmos and the motion of planets.
Good evening, Kepler. Before we dive into your groundbreaking work, could you tell me a bit about yourself? How did you come to be involved in the study of the heavens?
Certainly. My name is Johannes Kepler, born on December 27, 1571, in Weil-der-Stadt, a small town in the Holy Roman Empire, now part of Germany. From a young age, I was captivated by the stars and the intricate patterns they formed in the night sky. Although I initially pursued studies in theology, my passion for mathematics and astronomy soon took over. My journey in astronomy began in earnest when I became a mathematics teacher in Graz, but it was my work as an assistant to Tycho Brahe, one of the greatest observational astronomers, that truly shaped my understanding of the cosmos.
That's quite an inspiring journey, Kepler. I understand that your recent work has led to some groundbreaking discoveries about planetary orbits. Could you share what you've uncovered?
Indeed. For centuries, it was widely believed that planets moved in perfect circles, a comforting idea that aligned with the belief in a divine, unchanging order in the universe. However, as I meticulously studied the orbit of Mars, it became increasingly clear that this wasn't the case. The planets, in fact, move in ellipses, with the Sun at one of the focal points. This realization was difficult to accept at first, but the evidence was undeniable.
Ellipses, not circles. That's a significant departure from the traditional view. What led you to this conclusion? How did you come to realize that the paths of planets are elliptical rather than circular?
It all began with Tycho Brahe's incredibly precise observational data. I spent countless hours trying to fit this data into the circular models we had used for centuries, but it just didn't align. After much frustration and contemplation, I hypothesized that the orbits might be elliptical. To my surprise and relief, the data fit perfectly with this new model. The variations in planetary speed and distance from the Sun made complete sense under the elliptical model. This breakthrough led to the formulation of my first law of planetary motion.
That's a fascinating discovery, Kepler. And from this first law, you were able to develop additional laws governing planetary motion, correct?
Yes, that's correct. Once I had established the elliptical nature of planetary orbits, other patterns began to emerge. My second law, which states that a planet sweeps out equal areas in equal times, was the next major breakthrough. This law explains why planets move faster when they are closer to the Sun and slower when they are farther away. It was a revelation that further confirmed the elliptical orbits.
It's incredible to think that such a simple shift in perspective, from circles to ellipses, could explain so much about planetary motion. But you didn't stop there, did you? You went on to discover a third law.
Indeed, my third law was perhaps the most satisfying of all. It reveals a precise mathematical relationship between the time it takes a planet to orbit the Sun and its average distance from the Sun. Specifically, the square of the orbital period is proportional to the cube of the semi-major axis of its orbit. This law not only unified the movements of all the planets but also provided a key that would later be used by Isaac Newton to develop his theory of universal gravitation.
Your work truly laid the foundation for modern astronomy, Kepler. It's amazing to think that your laws have stood the test of time and continue to be fundamental in our understanding of the cosmos.
Thank you. It's humbling to know that my work has had such a lasting impact. These laws of planetary motion were not just a culmination of my efforts, but also a tribute to the meticulous observations of Tycho Brahe. Together, we have contributed to a greater understanding of the universe, and I hope that future generations will continue to build upon this knowledge.
Kepler, your contributions to science are monumental. Future generations will undoubtedly look back on this era as a turning point in our understanding of the cosmos. Thank you for sharing your journey and discoveries with us.
It has been my honor to contribute to the grand tapestry of human knowledge. I believe that these laws will serve as a foundation for future discoveries, not only in astronomy but in all the sciences.
Johannes Kepler's laws of planetary motion revolutionized astronomy, providing a precise mathematical framework for understanding the orbits of planets. His work laid the groundwork for future scientists, including Isaac Newton. In the next episode, we'll explore the groundbreaking work of Isaac Newton, whose laws of motion and universal gravitation formed the foundation of classical mechanics. Johannes Kepler was a real historical figure whose laws of planetary motion changed our understanding of the solar system. If you're fascinated by the stories behind the greatest scientific discoveries, make sure to follow and subscribe. Join us as we continue to explore the moments that changed our world.